All right, so here we are, recursion part 2. So let's look at this again. So we've got a function here that we have a nested array, and this is something that we're going to be doing with recursion in just a bit. But for a moment here, let's just look at a function which helps us loop through a nested array. The way that we currently have written our function, however, it's just logging out each element. If we, if you look on line 3, we grab the element of each, using the index, we grab the element of each part of the array, and we're just console logging it out. So if at this point we were to console log things out, we would actually get the first number, which is a 1, and then we get an array with 2 and 3. So that actually that could be helpful in some situations, but currently if we are trying to access all the individual numbers, this would not be helpful. So let's figure out how we can do that and actually access all the numbers, no matter if they're nested or not. So if we have, and again, we're still using our for loop. We're still using a for loop to loop through the array. However, we're now making this recursive solution, like we talked about before. And as we go through the array, if we see something is an array, we're going to call this whole function again, logs an array, which can then process it again using that smaller piece of information. And again, since we're using console logs here, we're not returning anything. It does make things a little simpler. And the console log is happening in real time. It's not something which is getting passed down through different layers of the recursive call. However, this is something a little different here, is instead of using just an if and else or returning something, here we're using a for loop to loop through the array. And that's very convenient because if we're working with an array or something and then we want to, so we can loop through the array like that. And in this case, in the previous examples we did this morning, we were often removing something from an array or in a string to make it smaller. Here, this is a little different. We're actually just looping through the array without making that array smaller. But what we are doing is we are taking each element and passing it back. If it's an array, if the element is an array, we're passing it back to a new call to the function. And so that piece is smaller, and that's a smaller array that's getting passed in there. So if we were to do this now, we look at our call stack. So we get that first call with the full array, which is actually, yeah. And we get the first element is a 1, and the second time it gets called, it's actually the second element of that main array, which is a 2 and a 3. And I do realize, I think there is a typo in the call stack. At the bottom, it should be brackets around the 1, 2, and 3, the second set of brackets. So please ignore that, but that's one larger array. And then the second time it goes on the call stack, we have the smaller array of 2 and 3. And then as we're going into that smaller, the second function, we're in the for loop now. So now we're going through that array, and we get a 2 and we get a 3. So the 2 and 3 both happen in that second copy of the function because we're going through a for loop. And then that gets pulled off, and we're back to the first function. The first function finishes executing. It doesn't have anything else to do. It gets pulled off the call stack. Okay, so now let's do that with a different example here. Now we have a string. As you see, we're setting an empty string in the beginning. And we're again going to be looping through an array using our standard for loop, setting our element just as a way of being explicit about this, not having to repeat it again. And we're adding the final string. We're appending to the final string plus equals to the element. So this would be if we had a single, would work for a flat array which is not nested. It loops through the array, and each element is getting added to the string. So that works fine for this flat array, A, B, and C. If we select the result, we get A, B, C. However, if we want to do that with a nested array, we have to check to see if one of the elements is a yet smaller array. So the only thing we do different here is before we add anything on line 5, we check. We use array.isArray, which is the easiest way to check if something's an array in JavaScript. We pass in the element. If it is an array, we don't just add the element to final string. We have to pass the element to concat else again. So another call to the function, which is expecting an array, only expecting an array. But if it's not an array, for our purposes, we're assuming it's either an array or a string. So on line 8, we add it to there. So that's the if-else like we had before. Are we going to, like we had in the example just before, where we're checking if something's an array, and if it's not, we're going to do something else with it. So if we go through this, and the last thing we do is we actually return the final string. So this actually happens in every time we have an array, we're going to end up returning a final string. However, the final string in the subsequent, the second, third, fourth, or whatever copies of the function that get created, it's the final string for that function. The only time we get the full final string is in that first call to the function, and we go through this whole process. And so the very last thing which happens in the entire program is we get to line 11, and by then we've already constructed a final string, which is the true final string, and that's what gets returned. So that should be our result. So if we console log our result, we'll see, we're actually going to step through this line by line here. So we have our call stack. So we have our final string plus equals to A initially, because A is the first element. It's not nested yet, it's just a simple element. So we get that A on line 8, because we go into the else. We check is the array, it's not an array, so we go to line 8, and that's where we get that. And so that actually, final string resolves to an A. That's very simple. But the thing is, we're still in a for loop. So we don't just end the program here. We go the second time in the for loop. The second time in the for loop, we get the B and C array. And so in that case, we actually enter the if statement on line 5. We call concat else again, and we get a new concat else with B and C. Now, inside of that, though, B and C is a flat array. So we just loop through that normally. We add B and C. We end up with BC. That's our final string for that second function, which we return on line 11. And then the concat else call that was on line 6 gets resolved to BC, A plus BC, and that's our way of stepping through that in a very linear way. All right. So let's see. So working with nested objects. So that was we went through that really quickly. If anyone has any questions, please let me know. So we just talked about going through arrays. Like we have, this morning we talked about strings, and we talked about arrays and numbers, which we all were talking about in terms of not being nested. The only thing we're different doing this afternoon initially is we're doing nested arrays, nested objects, which is going to be very similar to arrays. We're also going to use a kind of for loop to go through the objects. But I want to just emphasize the difference between arrays and objects. You're already familiar with that, but there are going to be some major differences here, which we'll have to look at. So a convenient way of going through the object is using a for in loop. Instead of using a for loop and using the length of the array, we can use the for in loop. And the reason for that is because we're going to be grabbing the keys of each of the properties in an object. If you remember, and I'll actually take a moment here to gonna just write this out real quick so we can see this really explicitly. I'm going to open up the file here. share my screen again. Okay, so let's say we have an array. Now we've seen this before. This could be holding, let's say a list of names here. So we've got an array here. So each of these is an element in the array. An object, and I'm going to call this array, and my object has a different notation here. So I want to point out here that when we're dealing with objects, we also have a list of things. However, it's going to be looking a little differently. And I know you guys are familiar with this. I just want to reiterate it. That might look something like this. So if you notice here, each of these is a property. We can call this a property. And it's separated by commas. This is not to be confused by a function where you're also using the curly braces. You see that? But you could have code happening here like let x equals to 100, and your code is generally going to be separated by semicolons. Don't put semicolons in your object. This will break it. This will not work. Objects, they're always properties separated by commas, and each property, sometimes you'll see it written like this too. Sometimes you'll see it with single quotations. That could be, that's also perfectly fine. But usually there's a standard way that people do it. For JSON, the JSON format, which you may see one day, you do have to use double quotes, just so you know. But for regular JavaScript objects, so always use commas. This is called could say a property of the object. This is usually called a key. This is called a value. So this is the value. This is the information we're storing. This is how we reference it. So if we're referencing the object, we could do it like that. Someone have a question, or maybe you're not needed. So this would I'm sorry, name one. So this will console log. If we run this will console log out Bob. And the same with this. And yeah, that's going to be Jane. Now you could also do console log dot name one. It's also perfectly valid. And something else to note, this is something which will help to avoid any more other confusion. This does not work. To be really clear, this will be undefined. Actually, this might even throw a type error, because name one is here. If you don't use quotation marks and you use the curly brackets, and I'll pull this out of here so you can see it better, this is referencing a variable. This is referencing the name of a key. This is like knowing it's like a string, which is saying that's the address to this. But if you use this, it's expecting there to be something like name one equals to Bob. So if you had this here, you could then use this variable. And we'll need to use that probably today. We'll have to have situations where we're going to have a variable and we're going to plug it into our object to find it. So I just wanted to point out that really quick and show that we're going to be looping through the object using the for in loop. And we're going to be, this is each item that we reference is going to actually be referencing a property. And when you do a for in loop, so we do for, let's say, key in my object. Please note as well that this key, this can be named whatever you want to. It could be named thing or whatever. But key is generally good to use because or it could be name. I would say either use something which is related to the object, or something generic would be key, because when this variable is going to get set to each of these. So that's important to know as well, that if we were to console log out key here, we would get name one, name two, name three. So that's important about the for loop. The other useful things about doing it this way is it's going to loop through it, and we're not going to have to know the length of the object. But that's a few things here. So if we wanted to get the value inside this for loop, we'd have to do my object. that key. So something important here, and again, it's key. If this is not correct, that would be assuming that there is something called key here. This doesn't exist, right? So we can't use that. Remember, this is a variable here, so it's actually referring to this. So I just wanted a few notes that will help make.
Would dot notation work there?
Yeah. So you could do. Oh no, I'm sorry. No, it would not work. So if we did dot notation here, so dot notation would be assuming that again there is a property here called key. So it would work if we had.
We should only use dot notation if we know exactly what the key is called.
Yeah, exactly. Yeah, perfect. So this and this, or it could be actually with single quotations. So this would be assuming that the key named key, right? And again, it's also like, you know, if this was named key, so then this would have to be, oops, this would have to be key as well, you know. So that's just good to know that the dot notation assumes we're talking about a specific key, and so does this bracket notation, which can be confused with this notation very easily, obviously. But if you think about it this way, if key is a string, and it is a string in this for loop, key is the same as, you know, it's going to be name1 or name2, you know. This evaluates to a string. So this actually ends up as name1. So it actually is doing the same thing. It's just that the variable is evaluating to a string, which ends up something like this. It ends up something like, you know, name1 or, you know. So that's the same thing here. It just has, because it's a variable, has to evaluate. And the string is the string, or the dot notation is the way we reference the address, the key of the object directly. So there's some quick refresh on objects and all that stuff, but it's gonna be helpful today because otherwise you may be having some of these problems come up as well. Is that clear? Okay. I know some of you guys have that down really well, but it's still probably helpful to review that. So we're back to our nested objects. So we're for in loop, and if the value is another object, you guys can see my screen, right?
Yeah.
Okay, good, thank you. Just wanted to check. So we're going to use the for in loop. If it's an object, we're going to call the function again on that nested object. So we have this sum vals function. We're using the for in loop like we just described. And we use the for in loop because it's, again, it's convenient because we can do that with objects easily, and objects, it'll give us the key that we need right away. So we have the value we're setting to the object key, like we said before, that's getting the value on the object, and we're using the key like a variable here, not like a it's not a dot notation, or it's not with the quotation marks. So each time we get the value, we're adding that to our sum, and we're returning the sum. So this is working for if we had the object. It's not nested, it's just a flat object with a bunch of key value pairs. So if we do that, we're going to get 30. Now we can do it in a nested way. So now the assumption here, as I'll show you, here we don't just have a simple object which is flat. Some of the properties, some of the values in this object are yet another object. So if you see where the B colon is, it's not pointing to a number. It's pointing to another set of brackets, which is holding, you know, and this happens a few times here. So here the idea is that on line 5, instead of like before we were checking to see if array is array, this is our way to see if it's an object, if type of value is equal to object. And so if that's true, we have the sum, but instead of simply adding the value, we add the recursive call, which is going to then process that smaller object. And if it's not an object, we're assuming it's just a number in our case, we can just add it to the sum. So if we go through that, we can see us processing that. So the first thing we get is a 1 that gets added to the sum. And then 1 plus a second call to the function, which is that smaller object, that gets processed. But because we call sum vals again, it gets added to our call stack. Our sum starts at 0. And then it becomes 0 plus a call to the smaller object. And this happens until we get to a situation where we're not calling the function. We just get a 0. So the last time we call it, we're looping through that for loop as many times as we need to, but each time we're not calling the function again. We're just doing on line 8. We're just adding the value. So we add the 2 and we add the 3. We end up with 5. The 5 gets returned on line 11 from that top layer of the function. It gets returned down into the previous call to sum vals, which gets added to the 0, and so on. And so because there's only one element in this function, we only loop through it. We only have to loop through it one time. You see here D on that third layer there just has one object. We only have one key value pair actually on that layer of the object, and the same goes with the previous one. So we just add the number progressively, and then finally the 1 that was from A gets added to the B, the result of B, and we get 6. So I hope that was a more clear example of how to go through those objects. So nested structures and recursion data structures. So you see the basic idea is that we're checking to see what the data type is, and depending on the data type, we're going to be doing different things. So if we're, say, just dealing with arrays, we can go into the array and check is it, say, a number or another array, and that will determine whether we add it or call it again. And because we're dealing with a for in loop, or these for loops as a way of going through these data structures, we're not going to be dealing with, say, the base case in the same way. We simply exit the for loop. That is our that's the way we know that we've finished that layer. And our base case is essentially when we don't have to call the function again. We don't call the function again if we don't have another object or array that's nested. So that's our base case. Our base case is there's no object to be called on this layer, or there's no array to be called on this layer. So with arrays, we are using a regular for loop. Objects, we're using a for in loop. And as we went through those examples, we have slightly different approaches for that.
I have a question.
Sure.
So is the base case basically just the for loop, because it'll stop running once? Is the base case the for loop in a way?
Yeah, I think that's accurate. That's as I was starting to answer that before, I was thinking about the best way of describing that, and I think that's accurate. So the base case would be, we don't have an explicit base case where we're saying, if this or that, we're going to return 1 or return true. But the base case would be where we exit the for loop and we haven't called the function again. So in the topmost example, the top function we had before, we didn't have to call the function again. So we simply went through the for loop and we added a number to it and we left. So that's basically the answer. Yes, we exit the for loop and we haven't called the function again in that function. But having said that, it may be not so simple, because you may have objects which are nested in a more complicated way. And so you may end up, say, not calling the function again, going through the for loop, ending back in the previous layer, but then encountering another function which adds another layer again and it gets removed. Then you had maybe add 2 layers again. So the objects could be more complicated, so I don't think it's so simple to say that we haven't called the function again, but I think that when the for loop exits, the for loop finishes, that function has finished. And I think that's a good question though, and there may be a better way of describing what the base case would be. But at least we do know that there's the base case we're not formulating here as a separate thing in the same way. We have an if and an else statement, and we're checking to see if we should add it or not. And you could almost kind of say like in these situations, the else is the base case. But we can, I think as we go through examples, maybe I'll also like look at a better way of describing that, because I think it's not so clear how we describe the base case in the nested examples. But thank you for asking that. It's a great question. I'm going to go ahead and, well, if there's not, were there any other questions?